All right, lesson 2.1, writing and graphing inequalities. This might be review. This might be something you know by heart already, by heart already. Something you know like the back of your hand, or this is brand new to you, which is perfectly fine. I'm going to be treating it like it's brand new. And who knows, you might remember or learn some tricks if you already know this. But like I said I would do before, the hardest one I can think of for today's lesson: graph the inequality. Negative n less than or equal to 3 over 2. Whoops. 3 over 2. So, as per usual, 30 seconds. Let's put 0 here. If you can do this in 30 seconds or less, then I don't really think you need today's lesson, and maybe also partially the next lesson too. But go ahead and pause the video if you want to try that. I'll go over it at the end of the lesson. So, for inequalities, some things that you might not know or might remember: 4 different symbols. We have this one, which is less than. This one, which is greater than or more than. This one, which is less than or equal to. And this one, which is greater than or equal to. If you're in my class, you also know that for this chapter, we started using the student journals to see how they go. In this case, you would turn to page 30 in your student journals, and you might notice, as I will pull up in a second, that bottom half of page 30 has that section. Like here, page 30 of your student journal. It's the bottom half of the page. You have exactly what I'm writing right now. We have the words of x is less than 2, and then the algebra for it, and then the graph of what it looks like. For all of them, greater than 2, less than or equal to, greater than or equal to. So if you ever forget, want a little key or something, you can always reference that. Now, if you're in my class, it also means that you know on the top half of this page, there are some vocabulary terms, some definitions that I would want you to write in there, preferably in your own words. Sometimes, some of you might have this filled out already. If you do, that's okay as long as it's done. But a definition of an inequality. So you'd write this right here. A mathematical sentence that compares expressions. What does that mean? Well, let's say we have something like this. 2 is less than 5. We have a mathematical sentence, which is the whole thing, that compares, this is the comparison, expressions. If expressions, this side is an expression, this side is an expression. We could add some more things on there if we wanted to. We could do x plus 2. We could do 5 minus y divided by 4 plus 18. Those are expressions. So that's all inequality is. With that, a mathematical sentence, which means we can go from English inequalities as well. If we have a new page, let me get rid of, I get rid of this. Have, for example, number W minus, if I can write, minus 5 is less than or equal to -2. We can write this as an inequality. Just break this out. A number minus 5 is less than or equal to -2. Number W minus 5 less than or equal to -2. And that's it. Trying a second one. 3 is less than a number n plus 5. Parse this one out again. 3 is less than a number n plus 5. 3 less than n plus 5. So that's all it is, a mathematical sentence that compares expressions. Here we have the comparison less than or equal to, less than or equal to, less than. Expressions. Number W minus 5, -2. W minus 5, -2. 3 is the expression. N plus 5 is the expression. That's all it is. And if you're in my class, this is the part where I would tell you to do in your student journal. The next page over, do number 1 through 4. I'll pull that up so you can see. Next page over, 1 through 4. Trying to turn these sentences into an inequality. 12 is greater than or equal to 5 times the number n. 1/3 of a number h is less than 15. 7 is less than or equal to the difference of a number q and 6. The sum of a number u and 14 is more than 6. I'm actually going to decide right now. I'm going to do these right in front of you. So we have number 1. 12 is greater than or equal to 5 times a number n. Parse this out. We have one expression, 12, greater than or equal to the comparison, 5 times a number n. 12 greater than or equal to 5 times a number n. Two. 1/3 of a number h is less than 15. Eventually I'll make this easier on myself and be able to write on it directly, but for right now, I'm just putting it up. So, expression 1/3 of a number h, comparison is less than expression 15. 1/3 of a number h is less than 15. That's it. Next one. 7 is less than or equal to the difference of a number q and 6. My webcam's covering that part, but it's there. So we have 7, expression, is less than or equal to, comparison, difference of a number q and 6. If you don't remember, difference is subtraction. So we have 7 less than or equal to the difference of a number q and 6. Last one, number 4. The sum of a number u and 14 is more than 6. Sum of a number u and 14, expression is more than, comparison, 6. Sum of a number u and 14, u plus 14, is more than, greater than, 6. Done. Now, some more definitions. If we go back to page 30. What do we have? We have solution of an inequality. What is it? A value that makes the inequality true. That's it. Oops. A value that makes the inequality true. Actually, I'll move it so it's like this. There we go. So, for example, we have x is greater than 2. What's the solution to this inequality? 3 is greater than 2, so a solution is 3. Pause if you need to. The next definition, I'll make a new page real quick. But for this example, x is greater than 2, there's a lot more numbers that can be greater than 2 that make the inequality true. There's a lot of solutions. There can be multiple solutions to an inequality. That's what we call a solution set. The set of all solutions of an inequality. So in this case, x is greater than 2. The set of all solutions of an inequality, in just words, is any number that's greater than 2. Okay, a little bit of a skip here. That's okay, because I basically just figured out how to make things easier for myself on these. But with these definitions, these new definitions, a solution set, which now I can show you from right here, should be up here. So now we have the definitions of inequality, solution of inequality, and a solution set. Now, a skill to have, since now we've gone from English to inequality, and now we know what solutions are, let's try to see if we can figure out how to check if solutions are correct. For example, we have checking solutions. Tell whether -4 is a solution of each inequality. What does that mean? That means we will basically just plug in -4 for the variable. Do the math, see if it makes it true. It's also very bright. So we're just going to plug this in. -4 plus 8 is less than -3. -4 plus 8 is +4. And now let's think about it. Is 4 less than -3? No. 4 is greater than -3. So this is not a solution of this inequality. -4 is not a solution. Now let's try plugging in for here. -4 times -4 greater than -21. -4 times -4 is +16. Greater than -21 is 16 greater than -21. Yes. So -4 is a solution of this inequality. Now from here, if you're in my class, so I'd ask you to do in your student journal the next set of problems. Page 31, number 5 and 6. Page 31, number 5 and 6. So these ones. Tell whether the value is a solution of the inequality. Here you have the inequality, and here you have the solution that you're trying to test. So just plug it in for that and see what happens. Try to see what happens with the math. D equals 19. 19 minus 7 less than 12. 19 minus 7 is 12. Is 12 less than 12? No, 12 is equal to 12. So that's a no. Let's try this. N is equal to 1. So 3 times 1 plus 6. 3 times 1 is 3 plus 6. Is 9 greater than or equal to 9? Yes. So this one is a yes. You remember from elementary school or something with these symbols, if you treat this thing like an alligator, this symbol like an alligator, it's got teeth, it's got eyes, alligator eats the bigger number. So in this case, this one would be true. 19 is bigger, it eats the bigger number. 20 is greater than 1. 20 is bigger than 1. The symbol faces eating the bigger number. So next up, so our next definition. Go back up here. I'll just write it here instead. Graph of an inequality. A graph of an inequality shows the solution set of the inequality on a number line. So, we have an inequality, a sentence that compares two expressions. A solution of an inequality is a number that makes the inequality true. A solution set is all of the numbers that make the inequality true. And a graph of an inequality shows the solution set of the inequality on a number line. Because if we want to write out, okay, we have the example I used before of x is greater than 2. There's a lot of numbers that are bigger than 2 that would make this inequality true. So that's where we use graphs. The shaded in part of a graph represents the solution set, represents all the numbers that can make the inequality true. So for this, you would just shade in all the numbers that are greater than 2. And that's what this is for. So if we graph the inequality, y is less than -3. Less than or equal to -3. Let's do that. A number line right here. Even if we start at 0 right now. 1, 2, 3, that's 3. 1, 2, 3, it's -3. And we just keep going. How do we do this? We start with the number that we're given. That's where it's going to start. -3. So we have -3 right here. We're starting here. Now, when we're graphing inequalities, there is something that we would do. If you remember, an open circle versus a closed circle. An open circle on the thing where it starts means it's not shaded in, which means the number is not a solution of the inequality. So it's only when it's greater than or less than, basically. A closed circle or a shaded in circle means that number is shaded in, which means it is a solution. It can be equal to that number. In this case, we're at -3. We have the symbol. It's equal to. So it's going to be a closed circle on here. Your thing is like, okay, alligator eats the bigger number. -3 is the biggest the y can be. The line that we're drawing, the graph that we're doing, represents all the numbers that y can be, all the numbers that make the inequality true. So e's the bigger number, -3 is the biggest number it can be, so it's everything that's smaller than -3. You can do squiggles because that's easier to see than just like drawing on this like side to side. You can do above the line, close circle, go this way. You can do draw the closed circle and you do a line this way. However else you want to do it, you can even write closed and then do the line just to make sure I know that it's closed. If you do it too small, I'm not going to know the difference between something like this or something like this. It's very, very tiny. I'm going to zoom all the way in to see what the difference between that is. I can't do that in real life. You'll need a magnifying glass for your paper. So, let's try another one. Graph the inequality. Oh, something else I almost forgot. You can test to see if you're right. You can test solutions. So, if we test, what does that mean? That means that means you take a number from the left of where the number line starts and the right of where the number line starts, and you just see if it's true. Take a number from the left, so the left of -3. Let's do -5. Plug that in for y. -5 less than or equal to -3. Is that true? Yes. And we're good. It checks out because, like I said, the shaded part of the number line means it is a solution. -4 would be right here. It's shaded by the line, so we're good. The right side, so the right of -3. Let's choose 0. Plug that in. 0 less than or equal to -3. Is 0 less than or equal to -3? No. And if we check on the number line, is it shaded in? No. And we're good. Now let's try another example of graphic inequality. 2 is less than x. Draw another number line here. I'll just do 0 right here. I'll do every 2 tick marks. This is why I love graph paper. 1, 2, 1, 2, 3. These are negatives. Actually, I'll save this for myself. So, step by step, I'm going to go a little bit faster. We have the number. We start with 2. So, we're at 2. Open or closed circle at 2. It can't be equal to 2. There's no equal to there. So, it's an open circle. Open circle at 2. Or I can just write this above if I want to. Open circle at 2. Alligator eats the bigger number. X is bigger than 2. 2 is the smallest number that x can be. So everything is greater than 2. X is greater than 2. Goes this way. And that's it. If we want to test, left, let's choose -1. Right, let's choose 4. Plug it in for x, 2. -1. Is 2 less than -1? No. Which is good. It's not being covered by this line, so we're fine. 2 less than 4. Is 2 less than 4? Yes. 4 is covered by the line, so we're good. One more example. X is greater than 0. I'll copy paste that same number line here. So, what number do we have? We're starting with 0. 0 is right here. It's going to be open or closed circle. It's going to be open because there is no equal to. Open circle. Alligator is the bigger number. X is greater than 0. X is any number that x can be. It's bigger than 0. Bigger than 0 is this way. And that's it. You might notice this is just all positive numbers. A trick you might have noticed is, in this case, if you treat this like an arrow, it's a direction that the line is supposed to go in. But you have to be careful when you do this, because x greater than 0 is the same thing as 0 is less than x. It's just swapped. Those are the same exact thing. And if you follow that rule for this one, where it's pointing this way, you'd have your line pointing this way, and that's not right. So you have to make sure that x is on the left side. Whatever you're graphing is on the left side, and then you can use that trick if you want to. That being said, if you're in my class, next set of problems, student journal, page 31 to 32, numbers 7 to 10. I'll flip back to over here, starting on 31. Give you some time to try to do this on your own. So pause right now. I want you to try to do it on your own, and then I'll go over it. So, x is greater than or equal to 3. So we're starting at 3. 3 is right here. Is that going to be an open or closed circle? It's going to be closed because it can be equal to. So, closed circle, or we can draw it above. Alligator eats the bigger number. X can be greater than 3. X is always greater than 3. Greater than 3 is this way. Or if we treat it like a direction, because x is on the left side, x is greater than 3. X is less than or equal to 4. So we have 4 right here, open or closed circle. Closed because it can be equal to 4. Alligator eats the bigger number. So the bigger number is 4. That means x is less than 4. 4 is the biggest number that x can be. So x is anything less than 4. So this direction. X is on the left side, so you can use the trick of the arrow pointing that way. 9 and 10. We have -1 starting here. Is it open or closed? It's open because there's no equal to. Does not include -1. X is on the left side, so we can use the same arrow trick. It's pointing that way. Or, alligator eats bigger number. X is bigger than -1. So it's everything that's bigger than -1. And last one. X is less than 1. We start at 1. Open or closed? It's open because there's no equal to. Bigger number is 1. So x is less than 1. X is everything less than 1. So, back to this. We've gone from English to inequality, checking solutions of an inequality, graph or inequality to graph, and now we're going to go graph to inequality. So, for example, you'd have directions like this. Write an inequality that represents the graph, and it would be that it's like this. Looks like that. So now you have to write the inequality side. What we do is we start the number that the number line is starting at. So 4. 4. Is it open or closed? It's closed. So it's going to be it can be equal to 4. And if we think about it, 4 is the biggest number that this graphed in number line is. It goes, everything else is less than 4. So 4 is the biggest number. Alligator eats the bigger number. And just choose a letter. Any letter. Doesn't have to be X. And choose A. You can use the same arrow pointing trick so long as your variable is on the left side. Oops. Line is going this way. Arrow is pointing this way. You can test solutions the same way too. Test. One from the right. one from the left. I think that's opposite order of what I did last time. One from the left, one from the right. Let's choose, I don't know, one from the left. Let's choose 0. Is 0 less than or equal to 4? Yes. You can check that. The line is covered. 0 is covered by the line. From the right, let's choose 6. You can't see 6 over here, but it would end up being like out here. Is 6 less than or equal to 4? No. Which checks out. The line that we graphed in, the line that is graphed in, doesn't cover 6. So we're good. Some more math convention. If you wrote it like this, or you started that way instead. Math convention is you have the variable on the left side. So I will ask you to have your answer like this instead. Trying another one. Probably need another page. Let's do this one. So, step by step, but a little bit faster. Number line starts at -2. Is it open or closed circle? It is closed. Which direction is it going in? It's going this way, so simple will be like this. Choose a letter. Or, now we can think about it, the line covers everything that is bigger than -2. So, whatever variable it is, let's choose y this time. This shaded in part is supposed to be y. Y is always bigger than -2. And you can test it again if you want to. Test, we'll go left, right. Choose a number from the left, choose -4. Number from the right, let's choose 2. Is -4 greater than or equal to -2? No, which is good. Checks out. Our line does not cover -4. Is 2 greater than or equal to -2? Yes. Follows the inequality, and it is covered by the line. One more example. Say I had this one. So we're starting at 3. Is it equal to? Is it closed? No. So that's going to be just like that. What's shaded in is everything bigger than 3. So 3 is the smallest number that the variable can be. Let's choose like k. So k is always going to be bigger than 3. Like I said, preferably math convention, variable is on the left. If you hate me, you'll do it like this, because that also makes my life a little bit harder. That being said, back to student journal. The last bit of those problems, page 32, problems 11 through 14. I'll go back to it, problems 11 through 14. Again, try to do these on your own, but I'll walk through them anyway, just so you can check if you got the right one. So, let's start. Number line starts at 1. So we have a 1. Is it open or closed? It is open, it looks like. So there's no equal to. And it's greater than 1. Everything is greater than 1. 1 is the smallest thing it can be. So let's just do x. X is greater than 1. Next one, we've got 0 here. Open or closed? It's open, so it's not going to be equal to. It's covering everything less than 0. So 0 is actually the biggest number that happens on this line. Bigger number. Let's do p. Next one, -3. Starting at -3, is it open or closed? It's closed, so it's going to be equal to. It's everything greater than -3, which means -3 is the smallest that this number can ever be. So it's everything greater than -3, and let's do a. Last one, we're starting at 3. open or closed? It's closed. So it's going to be equal to. 3 is the biggest number that's shaded in on this number line. So it's everything smaller than 3. 3 is the biggest one. And let's do M. So there you go. As a recap, and then I'll do the hardest one. We have these 4 symbols, sorry, of greater than, equal to, greater than, less than, greater than or equal to, less than or equal to. And if you ever get lost, you have these core concepts on page 30 of your student journal that you can reference at all times. What it looks like in words, what it looks like in algebra, and what it looks like on a graph. Then we have definitions, what an inequality is. A mathematical sentence that compares expressions. This is the comparison. These are 2 expressions. Done. We went from English to inequalities. We have definitions of solution of an inequality and a solution set. A value that makes the inequality true, and because there can be multiple solutions, we just group them together. A solution set is all of the solutions of an inequality, all the numbers that make an inequality true. We learned how we can check solutions, just basically plugging in numbers for our missing variable, see if it's true or not. We learned how to graph inequalities, because if an inequality can have so many solutions, like there's a lot of numbers that are bigger than 2, we use a graph, which is on this number line. Basically, every part that's shaded in is a solution of the inequality. So instead of just listing off all the numbers that are bigger than 2, there's a lot of them, an infinite amount of them actually. We just shade in that part, and we have the insinuation that it continues in that direction. You learn how to test those as well, just plugging in a number from the left and from the right, see if it's true, see if it's not true. Does that match with what you drew on your line? And then we went the other way around, going from graph to inequality. Starting from the number, seeing, okay, if this line represents the variable, what can that variable be? If it goes this way, that means this is the biggest number it can be. Alligator eats the bigger number. If it goes this way, that means it's the smallest number it can be. Everything is greater than. Alligator eats the bigger number. You can do the same thing of testing left and right, just to make sure, okay, did you write your inequality correctly? You can double check, okay, is it covered by this line? Yes. Does it match what the inequality says? Yes, then you're good. And then filling out student journal, basically all of the pages, 30, 31, and 32. All 3 of those pages. So, let's wrap up. Try to do this hardest inequality. This is skipping ahead a little bit, but I'll tell you, if you really want to brute force it, you can. We can see, okay, at the very least it starts maybe at 3/2, but it doesn't do that because it's a negative n. I will explain this further in a future lesson, but I will tell you, this is the same thing as n is greater than or equal to -3/2. Why that's the case, like I said, I'll explain in a future lesson, because this was just writing and graphing inequalities. But if you know this, then you can do it from here. -3/2 is the same thing as -1.5. -1.5 is right here. Is it open or closed? It's closed because it can be equal to. And the line is supposed to be n, and n is bigger than -3/2, so it's supposed to be bigger than -3/2. So that's what that's supposed to be. That being said, if you're in my class, if you're currently in my class, if you have any questions, you can ask me next time I see you, or you can email me if you know my email, you can message me on Canvas, etc., etc. And if not, if none of the above, you can just leave a comment on this video, and I'll try to respond. And that should be it. See ya.